Hello everyone, welcome to lesson 15.2 on Millikan's oil drop experiment. Now, a couple of key things here when we're doing this. First thing, essentially we need to know what the experiments going on with the experiment. So what Robert Millikan did is he took a very fine mist of oil drops and allowed it to then fall through this tiny hole here through two charged plates. Now, these two charged plates can then create a potential difference that, because the positive plate is up at the top, can hold a negative charge upwards. Will accelerate a negative charge downwards. But here, what we're seeing is the induction of X-rays coming through at an angle, so it's not like beaming you right in the eye. The X-rays are coming through, and they're providing a charge onto the oil drops, and thus suspending them. So what we're seeing happen here is that the oil drop will have two forces acting upon it, a force of gravity and an electric force. Now, the electric force is rather easy to decipher. Okay, that electric force is going to be the electric field strength times the charge, which is what we're looking for here, and the force of gravity is just mass times g. Now, in this particular instance, the trick becomes finding what is that mass of the oil drop. And so while the oil drop is suspended here and before it takes off in one direction, essentially what you're going to need to do is you measure the diameter of that oil drop from here to here. Once you have the diameter, you can then calculate the volume, multiply it by the density in order to find the mass. And so that's a little tricky on how the mass was determined. When it comes to quizzes and tests, you're not going to need to figure out the mass, at least in my course. However, you may have to find the mass, or you need to you'll be given the mass and need to find something else with it. However, it's just good to know how that came about in the first place. So let's take a look at our first example here. We've got an oil drop with a mass of 9.8 times 10 to the negative 16 kilograms suspended between two horizontal charged plates. Electric field strength 2 times 10 to the 4 volts per meter. And the magnitude on the oil drop is what we're looking for. What is the magnitude of that oil drop? Should be a question mark there. So, with pretty much every Millikan oil drop experiment, you're going to have an electric force and a gravitational force. Now, in this case here, we are assuming that this is the positive plate and this is a negative plate. However, if we had those charges reversed, we would be holding on to positively charged oil drops rather than negatively charged. But either way, we are hoping that this is suspended, which means force of gravity is equal to the electric force. The electric force is just that electric field strength times the charge, which means mass times g divided by E gets you the charge. So mass, like all these numbers are pretty much given, so at this point it is essentially a plug and chug type of deal. Electric field strength 9.81 meters per second squared divided by the 2 times 10 to the 4 volts per meter gets you the charge. And so when you calculate that out, you get 4.8 times 10 to the negative 19 coulombs as being the charge. Now, interesting thing with Millikan's oil drop experiment is that almost every value that he got was a multiple of actually 1.6 times 10 to the negative 19 coulombs. And he then deduced that that had to be the fundamental charge, or the charge of an electron and proton. So to find out how many excess drops, well, if that's the charge total divided by that 1.6 times 10 to the negative 19 coulombs per electron, that means you've got 3 electrons total. Okay, moving on to our next couple of examples here. We've been given a weight. In this case, because we've been given a weight, that is the force of gravity. But what we've been told is not the electric field strength. We've been told the distance the plates are apart and the voltage, which means we're going to need to use that to find the electric field strength. As with all Millikan oil drop experiment questions, Fe is equal to Fg. Now, this is the electric field strength times the charge is equal to Fg. We're not going to change this to mg because we've got the weight already, 4 times 10 to the 8. But E, the electric field strength, is the voltage divided by the distance between the plates. Gets you Fg, or the charge, which is, again, what we're looking for to find out how many excess. We're going to take that force of gravity multiplied by the distance and divide by the voltage between the plates. Now that we've got these 3 numbers, you're going to plug those in, and in this case here, you wind up with 8 times 10 to the negative 12 coulombs. 8.0 times 10 to the negative 19 divided by 1.6 times 10 to the negative 19 gets you a total of 5 electrons. Now again, we're told excess electrons, which means we're assuming the positive plate is up here and the negative plate is down here. Now, in order to find that weight, that is a force due to gravity, what we're going to need to do is figure out, in example 2a, is what was the diameter, basically opposite of what Millikan would have done. Now, given the fact that the volume is 4/3 pi r cubed, we're essentially going to need to find the mass and then plug that, use the density formula to find the volume, and then plug it into here to find the radius. So let's start with that, finding the mass of the oil drop first, and that's mg. 4.8 times 10 to the negative 14 newtons is equal to m times 9.81, or you wind up with a mass of 4.9 times 10 to the negative 15 kilograms. And really that's just dividing both sides by 9.81. From that mass, you can find the radius of this sphere. Oh wait, first we need to find the actual volume. Now, density being mass divided by volume, or volume is mass divided by density, we're going to take that 4.9 times 10 to the negative 15 divided by the density, which is 0.85 kilograms per meter cubed. Kilograms. That gives you a volume of 5.756 times 10 to the negative 15 meters cubed. So given the fact that we now have the volume, this is what we're now going to plug into the volume of a sphere formula. Right? V is equal to 4/3 pi r cubed So instead of volume, we're going to substitute in the 5.756 times 10 to the negative 15, 4/3 pi r cubed, multiplying both sides by 3, dividing both sides by 4, and dividing both sides by pi. That's going to get you what r cubed is, and then you're going to need to cube root everything. That eliminates, that gets r basically by itself, and you'll find that that radius is equal to 1.11 times 10 to the negative 5 meters, or a diameter, because we're asked about the diameter, would be 2.22 times 10 to the negative 5 meters. Okay, lastly, we've got a question for you to try. So pause the video, pause it now, and we'll see if you get this one, and we'll see you in a moment. Okay, so you've had some time to take a look at that. Again, electric force and gravitational force is going to be on there. Electric force is equal to the gravitational force, where the electric field strength can be found by the voltage divided by the distance. Manipulate this around to find the charge, and this is just the magnitude of the charge. 9.4 times 10 to the negative 19 coulombs. We do not know whether this is going to be positive or negative. If the positive plate was at the top, this would be a negatively charged item. If the negative plate was on top, then this would be a positively charged item, which means that this could have either an excess of about 6 electrons, or it could have lost 6 electrons through the X-ray bombardment. Hope this was helpful. If you've got any questions, please let me know.